In July 2015, NASA's New Horizons spacecraft made history when it successfully visited the remote icy dwarf planet Pluto. The incredible images it captured during the flyby stunned scientists and space fans, revealing a complex and diverse world covered in mountains, valleys, craters, and even a vast heart-shaped feature that may be hiding a deep, slushy ocean. For the first time ever, we got to see Pluto in all its frozen glory. But it's not just the presence of Pluto's magnificent heart that surprised scientists when they first studied the images. Across this frigid landscape, many other unexpected yet fascinating features have also been discovered. You're watching V101 Space. My name's Rob, and if you enjoy my content, then remember to subscribe for much more to come. Before the New Horizons mission, we only had limited knowledge of Pluto's surface features. This was one of the best images taken by Hubble in 2002, showing a mottled orange, white and black world with a mysterious bright spot. Then, as New Horizons passed by the icy dwarf planet, it managed to capture some of the most spectacular views ever seen from space. By zooming in on this high-resolution image, we can discover many of Pluto's hidden features, some of which may surprise you, such as the discovery of a lake that once flowed with a mysterious liquid. This unexpected lake can be found in a mountain range just to the west of Pluto's giant heart. It is about 20 miles wide, which is about 32 kilometers wide, and appears to now be frozen. However, evidence elsewhere on the dwarf planet suggests that it may have once been a lake flowing with a liquid. A surprising discovery considering Pluto's surface temperature is around minus 230 degrees Celsius, which is minus 382 degrees Fahrenheit. Though it's not entirely clear what kind of liquid once filled this lake before freezing over, scientists believe it is probably liquid nitrogen. And it's not just here where liquid nitrogen could have once flowed. Hundreds of thousands of years ago, it may have once carved out riverbeds and crisscrossing gullies, as this amazing image shows. How liquid nitrogen can pool and flow on a freezing world billions of miles away from the sun is likely due to Pluto's surface temperatures and pressures fluctuating as it gets closer to the sun, warming the dwarf planet just enough to mess with nitrogen ice, driving it from a frozen solid into a gas. But occasionally, the conditions must be just right for the nitrogen to become a liquid as well, causing these surprising features that no one expected. One of the most interesting features on Pluto is its hazy atmosphere, as this stunning true color image reveals. The gas in Pluto's atmosphere is very different from Earth's, however. To start with, it is very thin, more than 80,000 times less, and is thought to be created when surface ice is vaporized by the sun's light. Scientists believe the haze is a smog resulting from the action of sunlight on methane and other molecules. This reaction produces a complex mixture of hydrocarbons that accumulate into small haze particles, which scatter blue light. As they settle down through the atmosphere, the haze particles form numerous intricate horizontal layers that extend to altitudes of over 120 miles, which is over 200 kilometers. As Pluto moves away from the Sun, however, on its 248 Earth-year orbit, it is thought that its atmosphere freezes, possibly falling as a type of snow to the surface, creating a layer of frozen material. Whether this snow falls as grains or snowflakes like here on Earth is a mystery. It may even be accompanied by fierce winds, such as a blizzard, or it may just resemble a light snowfall under a bitter, cold haze. In some regions, such as the heart-shaped feature named Tombaugh Regio, it appears that we can see a layer of nitrogen snow, which may have condensed out of the atmosphere and then settled on the surface. Among the most striking features found on Pluto are these large snow-capped mountains in the southern hemisphere that almost resemble the Alps here on Earth, as seen from the International Space Station. But once you take a closer look, you realize that they are actually very different. The mountains on Pluto are made of water ice frozen as hard as granite, and are covered in a type of snow composed of frozen methane. Some of these towering peaks can reach heights of up to 2.2 miles, which is 3.5 kilometers above the surrounding terrain, similar to the Rocky Mountains in North America. How they formed is a mystery. On Earth, mountains are typically caused by tectonic activity or volcanic eruptions. However, Pluto is not geologically active in the same way as Earth, so scientists believe that they were likely formed by a process called sublimation erosion. This occurs when frozen materials such as nitrogen or methane on the surface of Pluto are exposed to sunlight and sublimate, or transition directly from a solid to a gas. This process erodes the surrounding terrain, leaving behind towering structures like these tall, jagged peaks. Pluto looks as if it is replenishing its surface in certain regions, however, because there are numerous indications that a kind of cold, slushy lava has poured over its landscape at various points. These strange features are called cryovolcanoes, which are a type of volcano that erupts icy volatiles such as water, methane, or ammonia instead of molten rock. Cryovolcanoes can also be found on some icy moons in our solar system, such as Enceladus and Europa. And on Pluto, there are several mountainous regions that have pits or depressions on their surfaces, which could be the result of cryovolcanic activity. One of the most compelling pieces of evidence for cryovolcanic activity on Pluto is this feature called Right Mons. The mountain, which is located in the southern hemisphere, rises to a height of 2.5 miles, which is 4 kilometers above the surrounding terrain, and has a wide summit depression, as you can see in this incredible close-up image. If in fact it is an ice volcano, as suspected, it would be the largest of its kind discovered in the outer solar system. Across Pluto's heart, extensive fields of desert-like dunes can be found. These features are made up of material that seems to have been blown across the surface by wind, similar in some ways to the dunes found here on Earth. The movement of wind picks up particles and deposits them in a particular location. However, the dunes on Pluto are unique in several ways. It's possible that they were formed not just by wind, but also by the melting of nitrogen ice, causing sand-sized methane ice grains to be lifted above the ground by rising gases, and then swept away once they were airborne. Additionally, dunes on Pluto are much larger than the dunes found on Earth. Some are as tall as mountains and stretch for miles. This is likely due to the lower gravity on Pluto, which allows particles to be transported far more easily, creating these magnificent features. Also found across Pluto's heart are strange iceberg-like structures that seem to be fragments of ice that have broken away from the larger surrounding formations. Each fragment measures 1 to several miles wide, but what is interesting about these features is that they appear to be floating across the frozen surface below. Scientists think that the icebergs are massive chunks of frozen water because water ice is less dense than nitrogen ice. When the icebergs break off and are eventually pushed into Pluto's heart, probably by glacial flows, they become subject to the motion of the nitrogen ice below, as can be seen in the strange shapes covering this region. These cell-like formations reveal the secret of Pluto's heart, because they are the signatures of a process called convection, which appears everywhere a fluid is warmed unevenly, like when you boil water in a pot. Evidence of convection means that something underneath Pluto's heart is warmer than the surface, and is causing this great plain of frozen nitrogen to slowly churn over the course of possibly millions of years. And if you look closely, you will notice that the icebergs are all generally gathered around these convection cells, because they are likely being pushed to the edge by the forces below. Before New Horizons visited Pluto, we only had limited knowledge of what its surface looked like. Now we have seen it in all its wonder and glory. We have discovered many of its fascinating features, some of which we explored today. Every time you take a look at Pluto, it seems like something new can be found, and Pluto is just one of potentially hundreds of dwarf planets in this region called the Kuiper Belt. Can you just imagine the wonders that exist on the other dwarf planets that we haven't visited yet, such as Haumea, Makemake, or Eris, for example? One day, hopefully, we will see them in all their frozen glory as well. I hope you enjoyed this video. If you did, then why not watch another? There is plenty to choose from. Thank you for watching, and I'll see you next time.